So why is it important to think about variables? Well, I would argue that it's not only important to think about them, it's also important to write them down. And the reason for this is that we often have judgments about what is important and what is not important in an experiment. And sometimes we can make grave errors in those assumptions.
As an experimenter, it's important to keep track of what your independent variables are and what your dependent variables are, because both of these are really important for setting up your experiment, carrying it out, and also analyzing the data afterwards. And to keep them straight in my head, I often think of the phrase, what is the effect of X on Y? The X is essentially your independent variable, whatever you yourself are varying or altering in the experiment. And the Y is your dependent variable, so what you're tracking. So an example specific from my project using this phrase would be, what is the effect of water availability on root patterning? The water availability is the independent variable. Root patterning is the dependent variable. You can think of controlled variables as factors that you are consciously making sure do not change from one sample to the next. And so for my experiments, I was making sure that the light conditions of the experiment were kept constant. So all the plants were experiencing the same lighting environment. So that would be a controlled variable.
When you do in vivo work, there is also variables that are associated with the animals, like the age of the animals. So when we injected the wild-type cells and the HER3 knockout cells, we made sure that all the mice that we were injecting were the same age. This is critical because if you inject one of the cells in mice that are slightly older, that can affect the tumor growth in these mice.
A confounding variable is something that will differ from sample to sample in a way that you are, for whatever reason, not keeping track of, or you're not keeping consistent. And the presence of this confounding variable can also make your experiment more difficult to interpret.
In our laboratory, we've done many experiments in the past using RNAi knockdown, and we found variability in the level of gene knockdown, even though we try to keep all the conditions exactly the same. And after quite a bit of time, we traced down the quote-unquote confounding variable, and it turned out to be a very specific lot of serum. And we discovered that some lots of serum from this one company allowed effective gene knockdown by RNAi, and other lots of serum didn't. So I think in these situations, it's really critical to then do experiments where you can test one variable at a time. If your variables are constantly changing and multiple variables are changing from one experiment to the next, it just becomes very, very confusing to compare results from different experiments and interpret them. So being methodical and really thinking through the variables, changing variables one at a time so that the results of an experiment are clearly interpretable also allows you to navigate your project in the most linear and successful path.